Alright, welcome back to another Kotlin LeetCode video. Today we're going to be working on middle of the linked list, so let's switch over to that. Given the head of a singly linked list, return the middle node a linked list. If there are two middle nodes, return the second middle node. So I've actually done this one before, although in Java, and this one is not entirely too difficult. I believe this is just another one that is using the two pointers pattern. So basically what we'll do is that we'll have a fast and a slow pointer. So this is very similar to something like finding a cycle in a linked list. That's one of them. And another one that'll be coming up that'll also use this fast and slow pointer approach, I believe, is going to be the palindromic linked list to see if the linked list is a palindrome. Basically what you do for that one is, I believe, you just go to the halfway mark, and then you start reversing it, and then you start at either end and you compare the values. In any case, we're going to start with this one. We're going to start with the 2 pointers pattern, and we're going to do a fast and slow pointer. So we'll start with a var slow pointer. We'll have that set to head. Var fast pointer will also be set to head initially. And since the number of nodes in this list is in the range of 1 to 100 inclusive, that means that we don't have to worry about, in this case, we don't need to worry about a situation where our head pointer is actually null, or basically a linked list of size 0. So let's go on and say while fast pointer is not null, then we'll say slow pointer is equal to slow pointer dot next, and fast pointer is equal to fast pointer dot next question mark dot next. So this is checking if it's null, because we want it to move 2 spaces, but we also want to make sure that this value is non-null. We're probably going to need to also do the question marks here as well, because head is of type list node question mark, so nullable. So we need to make sure that that's also not nullable. And then at the end, we can just do return slow pointer. So basically what this will do is that it'll move the fast pointer 2 times, it'll move the slow pointer 1 time. So in theory, because the fast pointer is moving twice as fast as the slow pointer, then it will reach the end of the list by the time that the slow pointer is at the middle of the list. So for example, for something like this, we'll start both at 1. Slow goes to 2 as fast goes to 3. Slow goes to 3 as fast goes to 5. In this case, then, actually we want and fast pointer dot next is also not null, because when slow goes here, fast is here, slow here, fast goes to 3, slow to 3, fast will go to 5, and we want it to stop here. So that's when fast pointer next is null. So in this case, basically, if it's an odd length list, then realistically, this fast pointer should hit the end of the node, or the end of the list, the last node in the list. If it is an even list like this, so we'll start here. Slow goes to 2, fast to 3. Slow to 3, fast to 5. And then slow to 4. And then fast will go to 6 and then off. So in that case, fast will actually go to null. And in both cases, we will just return the slow pointer, since in the even case, it will go to the second middle node as we expect. And this is going to run in linear time, as per usual, because of the fact that we're just iterating over the list 1 time. Even though we have 2 pointers going through it at this speed, there's no nested sort of jumping that we're doing. Let's see, is there anything else that I missed? So you have a variable fast and slow pointer because we need to manipulate those. What about in the case of one? In the case of one node, well, we're checking if fast pointer is null and fast next is not. If both of them are not null, right? Because in that case, when they both start ahead, fast pointer's next is going to be null because there's only one. So in that case, that'll also work. Let's go ahead and run the code against our first example, our first test case. Let's run it against both of the test cases. And let's go ahead and submit. And there we go. Surprisingly slow, 11%, though it's a good question as to whether or not something can be done faster. I do know that for some of these problems, in particular the more popular problems, especially since I'm going off of something like the grind 75 list, there are a lot of submissions and that does drag the average down. Although this is surprisingly low percentage. I might take a double look at this in the future, but I think this is a decent enough approach that if you were to talk to, say, if you were to have this in an interview, I think this would be a sufficient one. I think the time complexity of it being linear is perfectly fine, especially since it is a singly linked list. There's nothing that we can do in terms of like making it even faster. And in this case, I'm not even sure if you could do it in a non-linear time because of the fact that linked lists are not sort of indexed. There's no way to sort of cut the search area in half as you would in a traditional sort of log n runtime solution. But this was a very, very fast problem, but hey, sometimes you get easy ones and sometimes you get the ones like the one yesterday with the diameter of the binary tree. Well, at least I know that 2 pointers is maybe the area where I'm more comfortable with, and maybe that binary trees and graph traversal is something where I need to actually practice more. But anyways, that's all for this video. I hope you learned something, and I'll see you in the next video.